Now, if you have not heard, we have been running a Crowd for Good program. Our first challenge was our Data Science Breast Cancer Solutions Challenge. And I'm really excited to bring up Pratik, who's the project manager on this project, to talk about what we have done and to hear from some of the amazing competitors who submitted to the challenge. So get ready to learn more about this program, see some really cool solutions, and see how you can get involved next time. Thank you, Pratik.
Thank you, Jesse, for the introduction. So I would like to, go over the Crowd for Good philanthropic initiative of Topcoder that we are that's currently ongoing. I just give it a brief introduction about it, and we can talk to our participants and about the submissions. Right. So this is our philanthropic initiative, which converts the typical work model into one with a pro-social incentive and directs community members to create solutions for the greater good. It started out in 2016 with Hewlett Packard Enterprise, and it has made a great social impact around the world. Right. Our current program focuses on cancer prevention, and we intend to create a self-sustaining initiative for cancer prevention and build solutions that empower the world to innovate. So we'll be hosting a round of data science challenges, design challenges, and also maybe programming in the coming times. And we'll engage more with the community. In the month of October, we had the first breast cancer prediction match, and which received a very decent response from our community with over 400 registration and 700 submissions. A lot of our data scientists were competing neck to neck to achieve the first position. It was a very tight competition, and I have two finalists who submitted in the same challenge, Vaikadehi and PJ Mathematician, who secured ranks in the leaderboard. And they'll tell us more about how they arrived at the solution. And there's more stuff coming up ahead. So, I think we have Vaikadehi and PJ Mathematician. So I would like to invite Vaikadehi to take over the stage and walk us over a solution.
Yes, thank you very much. I will try to share my screen as well for my presentation.
Sure, one moment.
I hope my screen is visible right now. So yeah, hello everyone. My name is Wei. Goes by the name Vaikadehi on Topcoder. I am a student in Belgium in the University of Antwerp in the field of artificial intelligence. I just started my PhD in the field of graph neural networks, and I'm very grateful that I can participate in the Crowd for Good breast cancer prediction match. So to discuss my solutions of these competitions, we first need to discuss about the data that we have received. The data that we have received is a tabular data containing various kinds of information which are relevant for the prediction. I roughly categorize them into three categories. The first one is the binary features, which has one value indicating whether or not the patient is of that class, whether, for example, if the patient has menopause, is Hispanic, has any previous breast procedure, etc. The second kind is the categorical features, such as the patient's race, breast density, and age at first birth. The last one are numerical features, which has been discretized, which is the number of relatives with cancer, the body mass index, and age group of the patient. Now, from these data, there is one very big problem. which is that 40% of the data are marked as missing. Now, this is not really strange because we wouldn't be able to collect all the data from every patient, of course, but this does pose a challenge for the machine learning algorithms, and therefore we need to have a solution. My solution to this problem is the usage of histogram-based gradient boosting algorithms, which has a built-in support for missing data, and at the same time, it is highly performant. Based on the description from scikit-learn, it is orders of magnitude faster than gradient boosting classifiers and other gradient boosting methods previously proposed. And it also has the convenience, of course, that we can optimize for various different scores. Here, we are focusing on the AUC score as it indicates the performance of the algorithm better without ignoring the class imbalance that we have in the data. And of course, the gradient boosting algorithm intrinsically already handles the class imbalance by focusing on the predictions which was wrong in the previous iterations. And finally, histogram-based gradient boosting algorithm also has a variable which you can set to indicate the categorical features, and I use that to indicate some of the categorical features that I have showed before. And I believe that it has also bring a increase in performance. Lastly, I also did some tweaks on top of the raw data that I have received to achieve my final performance. So I tried to split the categorical features into multiple binary features. This way that I think the algorithm will have an easier time in recognizing the data and training the data, training to get a better performance. Secondly, the hyperparameter optimization, which is very traditional. I just tried a linear search in all of the parameters that's of the algorithm, and I found that by increasing the max leaf nodes of every decision tree, that this gradient boosting algorithm is trying to train gives a better performance, and it also probably helps with the generalization and the training speed. And my final algorithm has achieved a final performance of around 99.1% AUC score. Yeah, that is the summation of my solutions. Thank you very much. Are there any questions?
So I had this question in mind when you were preparing your solution, right? What difficulties did you face when you were working on modeling your solution?
Sorry, can you say your question again?
So my question is, what difficulties did you face when you were coding, right? When you're training your model, or when you saw the challenge statement, what was the first thought you had in your mind?
The first thought is definitely that, yeah, there is a lot of missing data, and I was unsure how I should handle it. So my first approach when I see the data is actually I should probably apply some neural networks to, well, learn to deal with the missing data. And that the deep neural network approach actually didn't work very well because first we see that there are many data, and we are not really know which of the data are more relevant than others. And secondly, there is a heavy class imbalance, which deep neural networks doesn't have a built-in way of dealing with. So my biggest challenge in building a solution, I would say, is to find the correct method or the most optimal method that I should use for this kind of data. I must say, even though I am graduated in the field of artificial intelligence, I'm mainly focused on deep neural networks, and I am less familiar with methods in traditional machine learning, such as the histogram-based gradient boosting. And after that, I have found this method. It's actually very smooth sailing, I would say, for me to achieve the best performance.
That was really, really a different approach, right? And I'm glad it yielded very fruitful results. Our community wants to know, why did you want to participate in this competition?
So yeah, I wanted to participate in this competition because, first of all, I think it's a very good cause. My mother actually also has a breast tumor, so I found that I can relate very well to the other people that may suffer from breast cancer, and I feel like that I should do something that I can do, and I should use what I have learned in the past years in order to have a chance of helping other people with the same issues.
Well, that's really inspiring, right? We are working to have a great social impact at scale, right? And I'm sure that this will certainly turn up and help a lot of other peoples, not just who are a part of Topcoder, but also beyond this, right? Okay, so that was really good. Let me check if there are any further questions. So yeah, I think we can go ahead. Thank you for your presentation and for your time, Vi. It was really nice interacting with you and sharing your knowing to know your approach and your solution to this greater cause.
Thank you for having me.
Hey, Pratik, before we move on, there is one question in the Q&A from they want to know, what performance did you give without hyperparameter tuning way, if you can answer that.
Just using the methods without hyperparameter tuning, I was able to achieve around, I think, 98.2% performance. So it's definitely also really, really good. But I think with a little bit more hyperparameter tuning, because I also didn't do a lot of it, it could probably achieve better performance.
Yeah, I think the run is always for making the model fine-tuned right and getting the optimized results. That was a really brilliant insight, right? I think we should move on to our next speaker. Thanks for your time, Vi. And Pujan, if you can come on video and share us with the solutions. Yeah, so why don't you tell us about yourself and why you decided to participate in this challenge?
Hi, I am Pujan, PJ mathematician on Topcoder, and I am an undergraduate student in Delhi. I do machine learning and data science as my hobby, and I decided to participate in this Crowd for Good initiative because it's a really nice cause to contribute to, and I would love to share what I have learned and what I'm learning, and to use my skills for a greater good for the world.
Well, that's really nice. That's really nice. So when you saw the exact challenge published on Topcoder, what were your initial thoughts? How did you plan your approach, Pujan?
I will go through that in my presentation.
All right, sure. So let's go ahead.
So as Wei gave a very good description of the data provided and the columns that were given in the data set. So let's go to the next slide. I have plotted a correlation matrix of the columns that were provided. And this one, cancer, was the label that we had to predict. And as we can see that the lighter columns show that there is not much, not a good correlation factor, but the darker columns show that there is a good correlation. So if we see this invasive feature, we can see that there is a very good correlation with the cancer feature, which has to be predicted. And this invasive feature is the diagnosis of invasive breast cancer within 1 year. And we had to predict if the cancer is invasive or ductal. So this makes sense that invasive feature is providing really contributing really well to the cancer prediction label. So I have prepared some code snippets to show how much this feature is contributing. So I have used a logistic regression model, a very simple and straightforward model to compare the contribution of the features. This I only used the invasive feature to train the model, and just by using this one feature, I got an accuracy score of 99.2% and an ROC score of 88%. And then here I used all the other features except the invasive feature and got 96% accuracy score and an AUC of 77.6%. So as we can see that uh, the invasive, one of the features in the provided in the dataset is contributing more than all the other features combined. So here, to work with this type of data, we need to use several different models and combine them to get a better result. So this combining process is called ensembling, and there are many types of ensembling methods, but I will go show you what I have used. So I used gradient boosting models. Some of you here might know what are gradient boosting methods. So boosting is a type of ensemble modeling where we iterate through the data by building more and more models for each iteration and use the errors of the previous model to build the next model. And gradient boosting is where we use gradient of the errors, that is the difference of the predicted label and the truth label. And we use the gradient in the next iteration, as we can see in the diagram. So, so for gradient boosting, one can develop their own code and their own algorithm for gradient boosting, but I use the popular pre-coded libraries. And also, as we saw that we also use one of the gradient boosting methods, that is histogram based gradient boosting. So I used CatBoost and XGBoost. They are both open sourced and licensed libraries that we can use. And the main difference between these is that CatBoost uses strictly symmetrical decision trees, and XGBoost uses asymmetric decision trees, and both of them have very similar API structure, just similar to what we use in the scikit-learn models. So for my final solution, I trained a CatBoost model on the provided data and a separate XGBoost model on the provided data, and used another ensembling method called weighted average, where I just took 10:1 ratio of CatBoost and versus XGBoost and submitted my final predictions. Also, to add on top of this, I used k-fold cross validation, that is separated the training data into 4 parts, and then used those 4 parts to train my final models. That was to avoid overfitting. So I want to discuss some of the improvement factors that I think might be implemented in the future. I coded my models on a CPU environment, and hence they were a bit slower to train. Also, I used weighted averages, and the 10:1 ratio was purely based on trial and errors. So I think that I could have used better ways to combine the models, like stacking or other scikit-learn ensembles that they provide. Then interestingly, I didn't apply any type of pre-processing whatsoever, and I didn't handle the missing data, or nor did I apply any scaling methods also. So I think I for the past few months where I have been focusing on data science challenges, I have realized that in the gradient boosting methods like CatBoost or XGBoost, they do not enhance the accuracy of the model significantly when we apply any common pre-processing or feature engineering. So I straight up use the models without any processing done. And finally, I did not perform any hyperparameter tuning either. I think I was lucky. The stochastic methods uh, yielded a good result with just the default parameters. So that concludes my presentation. Thank you.
Sure,
Thank you very much.
that was really insightful, Poojan, right? I have a few questions for you, right? While you were competing here, um,
Hmm.
did you ever feel like, just let's stop it up, right? Did you ever feel like giving up on this challenge while you were optimizing for better scores?
Actually, yes. So while I was participating for the first 2 to 3 weeks, this I was like ranked on the. I think I was ranked seventh or eighth on the provisional leaderboard, and my score was just wasn't improving. So I took a break for 1 week and did not code at all. But then in the final week, I did like for to. Explain specifically, I was only using CatBoost without and like purely using CatBoost without using any other models. So in the final week, I decided to ensemble and use other models too, and I got a better result, luckily.
Yeah, that's really nice. I think a break sometime actually helps a lot, right? To just refresh your mind and then come up with the same problem with the new thoughts, right? So we have a couple of questions from the audience, right? One is for the k-fold cross validation. Did you use any method to deal with the class imbalance?
So for k-fold inval, I did not there are I know that there are stratified k-fold validations and um, other types of k-fold validations that the API provides, but I did not use that, and I purely started with the first index and went on with the 4 split k-fold without using any class imbalance. But yes, if I had done the validation split much more accurately, I might have used got a better result.
All right. All right, sure. Can we stop the screen share, please? There are a few
Yes,
more
yes, yes,
questions, right? Um,
yes, yes, yes.
so we have a question from Kit Singh. How did you come up with a 10-to-1 ratio of weighting? Was it a trial or a heuristic, or do you come up with a trial and error?
For this, I have experienced that while ensembling gradient boosting models, using like giving more weightage to cat boost and then very small relative small weightage to other gradient boosting models or any other model that I'm using works very well. So it was purely a very trial and testing method, and I started with 7, 8, 9, 10, 11, 12 with other ratios, and that worked.
That's nice. Right. Another question from KK Batta. Do you think if you had not used defaults and further tuned the approach or invested more time into it, do you think they can improve more and be more predictive and accurate?
Totally, I agree. And to be honest, I submitted my final submission around like 10 minutes before the submission deadline. So I think if I had some much more time, or if I had if I had applied better planned tuning approach, then my approach would have been much more better. Yes.
All right. Okay, that's really interesting to know, right? There's another question, right? Apart from the data science aspects, what are some key takeaways in terms of what we can learn from the data?
That's an interesting question. So I think one of them is that uh, while I was um, uh, the while I was going through the data, I think one of the aspects was that there were around 20,000 rows, if I'm not incorrect, 20,000 to 30,000 rows that were provided for training and many much more for testing. So that gives us the insight of how much that these data was collected from real patients of breast cancer treatment. So, which and that kind of made me very like uh, got me thinking that this was real data which was collected from real patients, and it was so much that uh, that this needs so much work, and we need to work on these type of data, and that was the takeaway from the data that was given.
All right. Okay, there's another question, right? How tough was the competition for you in terms of the other contestant submission quality?
Um, I think in the provisional phase it was pretty tough, and I was in the provisional phase. I was finally ranked, I think, fifth or sixth. But I think because one of two to three of my friends from my college also participated in this challenge, and from their feedback too, I think that apart from the data science perspective, the deployment code that we had to do so that the results can be reproduced, this deployment factor was also a major part for their learning, that we had to create like production level scripts, training and testing separate files. So this was also a factor that contributed to the submission quality.
Yeah, sure. But I believe that the competition makes everything better and more perfect. So I have this question for why, right? The same question, right? How difficult do you think was the competition in terms of submission quality?
Uh, well, yeah, in terms of other participants, I really feel the pressure, I would say. I think I had a bit more time in comparison to PJ mathematician. So I spent way more time in trial and error, I should say. Um, and I feel like, well, yeah, that everyone is doing a good job, definitely, at the competition.
All right, that's interesting to know. So another question that I have received is how are these solutions put to use? Which organization get access to this and put it to practice? So these solutions that we have will currently be a part of the Cancer Solutions Challenge, right? We have a series of upcoming challenges on cancer prevention, and we are actively looking out for the right people whom we can share these solutions to ensure that these actually go into practice and impact the people in real lives. And there's another question that has come up from kids. What are the key takeaways related to cancer prevention, etc., that we have from the challenge results? I think that the key takeaways is that our community is a really caring community, right? We are here to solve challenges. We are here to solve problems, some of the most difficult in the world, and also we ensure that we take care of all the social impact of all the social causes that exist in the world, of all the social problems, and use our skills and abilities, right, to make that impact, to make a better life for everyone. And it's really inspiring. It's really inspiring for everyone that we are working together and solving these challenges at scale, right? So yeah, I think there's another question. Can you guys share what resources, references you use to study and stay up to date with machine learning methods? Anyone? Pooch and why? Can take this up.
For me, I am a very frequent user of other data science platforms, and I am very constantly updated with the machine learning mastery blog site. It's quite good, and they frequently post updated data science blog articles. I uh, refer to them very frequently.
Yeah, for me, I usually get well recommendations from other students and professors, but I have found that websites such as Medium and Towards That Data Science, they often post blog posts of, for example, ICML conference, and these they also have people that make summaries on these conferences of interesting papers. So I just go through them some of the times to see what are the new trends in machine learning.
Yeah, I think staying up to date, particularly in our field of machine learning, is critically important, right? I think that industry is still evolving, right? And there's new things coming up every day, right? So Becky has asked, what would you, as members, like to see the next Cloud for Good that you could participate in? Any thoughts? Why or Pujan? What sort of
Well,
challenges would you like to see on Topcoder or contribute? Any social cause?
well, yeah, I would say that the introduction which was given by earlier about the drug discovery, I think it's already a very interesting challenge that I would want to participate in. But I would imagine just anything that helps the humanity in general, I would be very gladly to participate.
How about you, Pujan?
I think from for Crowd for Good, apart from the medical aspects, I think we can also uh, do data science challenges on the socio-economic factors that arise in different parts of the world, like economic or social, and we can use the data science method to correlate and predict the outcomes of the calamities or the problems that people face.
Yeah, I think these problems are some of the largest social challenges that we have, and it impacts millions of lives every year. Right, so certainly a lot of collaboration and a lot of brainstorming over these social challenges. I think our community can contribute to a greater good. It'll be really interesting to see interesting challenges and improvements in our existing solutions come up when we take up such challenges. Uh, yeah, there's also some comment regarding the first time participants. We had over 200 first time submitters in the October challenge, and we understand that there was some glitch, some friction in our submissions, and we're working there to improve and make it seamless. The platform team is ensuring that. And yep, we certainly have better instructions and more clarity on those lines. Right. So, other than this, I'm also curious to know, right, what more challenges would you think can expect on Topcoder, right? Would you like to explore, a higher degree of higher complexity of problems, and eventually land up in TCO, or something of those sorts? What do you think?
I think for me, I would love more complex data science challenges, like, for example, image based or language NLP based or any other type of multimodal testing, I think I am totally up for that.
Yes, for me, I would also like to see more challenging challenges in the future so that I can really put, for example, what I have learned in the field of deep learning in use as well.
All right. Sure. Certainly, we'll bring up a lot more challenges in the coming time. There's another batch challenge. It's a batch design challenge that we have launched today, and it'll be live in some time. So do make sure that you participate there and get some TCO prize packs for yourself, right? The badge is basically something that we'll award to those who made the baseline. Up to 10 winners get that, and there will be more exciting badges coming up, more exciting challenges in the coming time. I have a technical question, right? That is, if the goal was to make 99.9% accurate, do you know what it would take, not considering the cost in mind? I think this one was for PJ or Y. Anyone can take it up.
I think for me, I was focusing more on the provisional leaderboard while participating. But if my goal was to make it like 99% or hypothetically 100% accurate, I think it would take, first of all, uh, a very serious amount of feature engineering and data pre-processing, and then and then a very again very serious amount of effort in hyper parameter tuning, which I did not do. So if we also do that, I think it can achieve 99.9 accuracy.
All right.
Yeah, yeah, I would also like to add to that. I think even if we would have done our best because of all the amount of missing data that there is, we probably couldn't achieve 99.9%. So I would say that the availability of the data is definitely an issue for this challenge.
Okay. Okay. That's really nice. So we have a lot of newbies, right? A lot of noobs coming up on Topcoder, and they are very excited to, take part in data science challenges. What advice do you have for them? This is a question by Becky. Anyone?
Yeah.
Pujan, why? Anyone can take it up?
You can take that.
Yeah, all right. So I would say that to get the best performance, you really need to try different methods that are available. With the modern data science toolkits such as scikit-learn, you can really try different methods very easily with just a few lines of code. And I would say also don't forget to validates your data very well because that would have a big impact on the final leaderboard. Yeah, don't get too obsessed with getting a high rank on provisional leaderboard.
I think that's a golden piece of advice, right? Not to get a higher rank on provisional because final score also matters there. Anything from you, Pujan?
I totally agree with Wei that using scikit-learn as a starting step to get into data science is a really good idea, and that's how I also got into it. And then progressing very slowly and using different kinds of methods as we go is a very good idea to progress in the data science field.
Sure, absolutely. And I think what I have found is people stay with Topcoder for a longer duration as well, right? Those who are legends, they certainly move up on the leaderboard and they get to learn a lot of different ideas. They can make a lot of networks and do good for the community as well. There's a question for PJ. Did you mark the features as categorical, or how did you mark the features to cat boost or XGBoost?
So while importing the data from CSV, I use pandas, and pandas asserts the data types by the values automatically. So uh, all the data was uh, pre-processed by the categorical data was provided as integers, and there were some float values to float columns too. So the data that was provided to us was already processed by the integer parameters. So I did not specifically mark the features by myself. I just poured them into the model.
All right. Okay, I hope that answers questions of Jan. So there's a question by Zena, right? Did you guys check other metrics like sensitivity and specificity too? Way or Poojan?
For me, I tried other scores as well, definitely, such as F1 scores. But I'm a little too obsessed with getting a high score on provisional leaderboards. So finally, I only went to optimize the AOC score, which is the leaderboard score.
How about you, Poojan? Were you checking other metrics like sensitivity and specificity?
I only checked correlation for different columns, and then ROC AUC. I optimized my solution using ROC AUC.
Yeah, yeah. I think that given the kind of class imbalance, this is one of the comments, right, from our members. Given the kind of class imbalance the data set had, PR AUC would have been a better metric to evaluate than the ROC AUC score, right? Maybe, right? I think this is something we can still explore, and we can still test with the data. There's a question by Frank. Can you share a few resource materials for learning?
Um, Personally, I learned from this blog site, Machine Learning Mastery. But then I think Fast AI has a very good practical courses that are really very updated and very up to the mark for both machine learning and artificial intelligence. And I think that's a really good material source that we can use.
How about you, Wei? What are your secret recipes for learning machine learning and data science?
Um, yeah, I wouldn't say that I have a secret recipe, but I think for me it was more trial and errors in the field of practice than reading the theoretical part. But as for tutorials, I think um, yeah, as I discussed before, scikit-learn just start using it, start getting feel of how data really look like. I think for starters, maybe just participate in one of the challenges and get some hands-on with some real data will help you learn the fastest.
Yeah, I think that the first step is, the most difficult one. And once you take that step and the run actually starts, right? It's really nice to see how you guys have stepped up, and you're there on the leaderboards as well. I have a question from Penna, right? How much background do you have in theory of machine learning versus the practical side? Um, Poojan, can you take that up,
Uh,
please?
so I for most of the machine learning algorithms that I use, I initially only use the practical, like just hard code it and see if I am getting a good result or not. But then, just because of my own curiosity, I do look up the theory and the mathematics behind it. But I am totally not as on the same level as Wei. He has graduated in the machine learning, so he will have a better perspective.
Yeah, as I said, I'm more expert in deep neural networks. So of the methods that I have used right here, I also don't have the theoretical background. I don't know how histogram-based gradient boosting works, but um, yeah. So what I want to say is that to use these already invented methods, you don't really need to know a lot of them. But if you really want to get the most optimized scores, then you really need to learn the theory.
Okay, that's, I think, a really good insight that you shared. There's another question from a participant, right? They want to hear, your perspective of your opponent's approach, like each other's approach over here. Can you share them, Poojan, and why?
Yeah, maybe I will start. I think Poojan's approach is very interesting in combining two different methods. And I believe that there is definitely some gains in that because as we already see that there are different kinds of columns features that we have, and some are categorical and some are not. And yeah, some methods would have an advantage in these categorical features, while others better in binary features. So I think that's something that I will consider in the future too.
Thank you. And I am always like very impressed when you you used like a core scikit-learn model without with extensive hyperparameter tuning, and it is very impressive too. And you even scored in the top 10, so that's really impressive. And I will for me, I do not. I have almost stopped using scikit-learn models, and my first approach is always to go to the other APIs, and seeing a scikit-learn approach in the top 10, that's really impressive. It must have taken a lot of effort. Thanks.
All right, that's really interesting, right? To know the mind of opponents as well. There's a question by Sunil. Did you guys also calculate false positive and false negative, which is critical in medical domain? Pei or Poojan, how was your
I
approach?
think so the ROC AOC score that is used is really very related to the false positive, false negative perspective. And so in that sense, I think ROC score is good. But as I saw from my own while I was coding, that at after one point of time, we the accuracy score is my accuracy score was perfect 1.0, and only I was coding to increase my ROC score. That is the probability of the prediction. So I think the false positive, false negative was taken care of once my model was good enough after training.
Yeah, I also didn't really explicitly calculate the false positive and false negative rates, but I also noticed the same phenomenon as Poojan said, actually, that the accuracy is weirdly high, like 99% at the very start, but it's only the AOC score is still pretty low, and after the training, the AOC score only increased. So yeah, I actually just have the same impression as Poojan.
All right, all right. That's nice. That's nice to hear that. There's a question by Benjamin, right? How do you determine which data is most viable? What is the filtration process like? Wei, would you like to take it?
Yeah, so for me, while I was doing the hyperparameter tuning, I tried to feed in each of the features in separately to see which feature would or which combination of features would have a potentially gain on the final performance. But in the end, I don't really see a very big gain if I take out one feature or well, yeah. So in the end, I only just use the raw feature with some splitting of the categorical features as my final
feature. Yeah, I also tested each of many feature combinations separately while training to get a result. And also for selecting the columns, I think I will recommend using there is this random forest classifier in the scikit-learn API, and it provides feature importances attribute. This can also be used to determine which feature is contributing, and it's really helpful for hyperparameter tuning.
Well, thanks for those insights, right? I think these insights will really help in the upcoming challenges. There's also a suggestion by Jen that DC can reopen submission. That would be great for people to submit and learn later as well. So Jen, we have a lot of ongoing challenges as well right now, and there are a lot more data science challenges coming up. I think we have a practice challenge going on ML, and there are a few other challenges which are coming up. We have a lot of exciting challenges lined up in the month of January and thereafter. So certainly you'll get a lot many opportunities to submit your data science solutions to a lot of different challenges from different sectors, not just the healthcare, but also on other sectors as well. So that'll give you a different taste every time you take up a challenge, right? So I think that's the question that we had, right? If there are any more questions, feel free to put them up on the Q&A chat, and our participants will certainly answer them.
Thank you guys so much for being here. We really appreciate it for you spending your time with us today. I hope this was a learning opportunity for everybody, and I hope to see everybody in the next Crowd for Good challenge and in the Broad Institute one. So thank you, everybody.